Right, so guys, part A of this question asks to draw the plan and elevation of the intersecting planes A, B. Okay. So we're looking for a dihedral angle. So I'm probably going to dihedral angle of this is probably going to go up to here, but they also give us this x1 y line, so we're going to view over here. So I'm going to try and roughly put this in the center. Okay, so I'll start by roughly going around halfway and draw my xy line. Okay. Now they give me two heights, a 40 and 20. A 40 up 20. Okay, and my plan is 70 by 70 and it's a grid. So to be honest, I'd say the easiest thing to do is probably draw my grid, my plan down here first. 70 by 70 box. Okay, so the red pen is on my light lines. And we use black then for our heavy lines. We count up the squares and it's 2, 4, 6, 8, 10, 12, 14 squares left for 5mm boxes now. Back to first year graphics. Okay, and then the only thing you have to be careful of here then is just making sure that your in 3 squares there comes to the bottom corner. Is that you just make sure you join up the points correctly. Comes across 2 squares then. Just say it's in 3 squares and up 2. Okay. Joins back here. This guy then is in 1, 2, 3, 4. 1, 2, 3, 4. So 1, 2, 3, 4. 2, 3, 4. There we go. And 4 squares. No, he's not actually. He's in 4 squares, in 4 squares. And then you have to split this lad in half. Okay. And that goes out to there. And that goes up to there. So that'd be a key point there now, is knowing that that box was actually split in half. Okay. Q is down here. And then P is 1, 2, 3, 4, 5, 6, 7, up 7. 1, 2, 3, 4, 5, 6, 7. P is halfway. That's our line PQ. Alright, that's our surface A there. That's our surface B. I'm going to label them now. I'm going to label them A, B, C, D, E, and F. Okay, and I can project all those lines up to my elevation then, because all those points are going to be somewhere up here in my elevation. You're going to be up there. D is going to be up there, and E is going to be up there somewhere. Okay, and I'll draw my light lines across here. Now it's just a case of figuring out what's what. Okay, so look at my drawing there. This corner here is up highest. Okay, so that's going to be that corner. So that's going to be C. Okay, this middle point here, that's B, and that's up at this height. Okay, so that's CB. I concentrate on getting A, B now. Sorry, that's not B, that's D. That's D. Okay, so I'm traveling up there, that's D there. Over here then, we have A and B. No, sorry, that's not right. Yeah, I thought so. So that one's not actually D. This is on the ground here. I was wondering, yeah. So D is on the ground there. Okay, so this takes a little bit of figuring out. So that point there comes up, it's on the ground. And that means D will join to C to give us that front edge there. Okay, and then we have B and A. And B and A are over here, both of these, okay? So, because C is going to B and D is going to A, D is on the ground. So A is on the ground and B is this one. That's how we figured it out. Because otherwise you'd have D going up here, B coming down, and it'd be crossing, so it wouldn't give us a plane. So that's how we get CBA. Okay. Same over this side then. We have E and F. E is going to be on the ground because it joins to D. And F then is going to be up high. And that's in hidden details at the back. Okay. So that's how we set up the elevation and plan there of part A. Now, part B then asks us for the dihedral angle. So how do we get the dihedral angle? Well, same as what we've been doing. So set up parallel to our line of intersection. So BDC is the line of intersection because it contains both. And we're going to look up along here perpendicular to it. Okay. Set up an X1, Y1. And this is so we can find the true length. Okay, so I'm going to project up CB, and I'm going to project up all my points. I'm going to project up B and F, go up there, and A and E go up there. Okay. I'm going to take my heights. So D here is on the ground. Okay. C is up this height. So let's extend that up a bit further. So that's C there. Okay. B and F B and F are up 40, which is this side. B and F. And A and E are on the ground. Okay, so CD there. Joins back to EF, back to AE, and this is our true length. So we have our true length line there. Okay, so if we have our true length line, if we look along our true length line, we'll see where those two guys meet. So what do we do there? Well, we're gonna extend up our true length line, set up 90 degrees to it. Okay, X2, Y2, that's our X1, Y1. Okay, and then we're going to project out all our points out there. So BE are going out, and BF are going out. Okay, and we're taking our distances back from our X1, Y1 back to our previous view. So that's point E there. So our X1, Y1 back to our plan E, A, back to the line CD, CD, and we'll take F and E as well just to be sure. So when we connect, sorry. Well, I've gone wrong here now. I've marked my E in the wrong place. That's it. E is there. That's my E. And A. So notice there, look. Here when they came down they were here, but then because they came up here they swapped over, so just be mindful of that. B and F then. Yeah, there we go. B and F. That's F. And that's B. That's why it's important to bring out all your points. Okay, and when I join these A, B, C here to A, B, C, D together, it should give me a straight line. And C, D, E, F. Right, and that's our dihedral angle there. Now, part 2 of the question, or part C of the question then says, project an auxiliary elevation of plane A on the X1 and Y1 line and hence determine indicating degrees the inclination of plane to horizontal plane. So they've given us an X2, Y2 line actually out here. It's perpendicular to our line DA, okay? So why are they projecting it out here? We're looking for an edge here. So we would actually done this in a question, but we would have to realize this is. But here they're actually giving you the X1, Y1 line. So this has actually made it easier for us because we know we have to project a view out here. So set up an X1, Y1. Okay. All we're doing is projecting an edge view here. So I'm going to bring point B out. We're just projecting the edge view of the surface A, which is, in this case, I have it labeled ABC. Okay, so again, we take our heights. So AD is on the ground. AD is on the ground. B is of 40 mil. And C is of 60 mil. Okay, I can join them together. And that's my angle there that makes with the with my horizontal plane. So what you have to do now is get out that protractor and measure that angle. I have my protractor here. I don't have a protractor. I do have one somewhere. Here it is. Okay. So measure that angle there. And measures 1, 2, 3, 105. Okay, I measured 105. In the American scheme, it's 104. But to a degree or two, you'd be okay. Okay, so it's 105. That's part C of the question. Part D then is laser lighting is used to enhance the entrance to the hotel at night. The inclined straight line PQ represents the path of a laser beam. Determine the points of intersection of the line PQ with the planes AB. Well, this is actually a nice one, actually, to be honest. And how is it determined? Well, all we need to do is we need to first of all, draw the line PQ in our elevation, okay, which is up here, and it's down here. So I'm drawing the line PQ. Okay, now we want to determine where this line intersects this guy inside here. Now, if you look here, look, we have 2 points on plane A where PQ intersect the edges, and we have 2 points on plane B. So this is like what we would have done earlier on back in intersecting planes, okay? So how would I find where that line intersects this line up here? So I've got where it hits the edge of 2 planes, so I'm going to bring that up to where it hits the line. So this is BC, so I'm going to bring this point up to hit BC. Okay, and this hits AD, so I'm going to bring this up to hit AD. Okay, if I join the 2 of them together then, okay, where they cross my line PQ, that gives me a point of where PQ cuts through the surface A, and we do the exact same for surface B. Okay, so this is FC, so I'm bringing this point up to FC. I'm bringing this point up to EB or ED, which is on the ground. And again, just join those 2 points there. And where that crosses there gives me another point. That's where the laser cuts through surface B. Okay? And that's your full solution then. So, just a quick recap. Again, remember, dihedral angle, we get the line of intersection. We look perpendicular to it, find your true length, look along your true length line, get your angle out here. With this question, we're looking for an edge view, so we look an angle in relation to the ground, so it's surface A, so we're looking out along a true length. This is a true length because it's horizontal in our elevation. Look out here, we get our angle, we get an edge view of the plane, okay? If they wanted the true shape of that now, we could just look up here, set up an x2, y2, and then you take the distances back here, okay? And then this guy was just taken where it crossed in plan, bringing it up, setting up 2 points, and finding where it crossed. Okay, any questions, let me know.